Okay, welcome to Fortran Bootcamp Part 4. This is where it's really going to start getting interesting. We are going to talk today about functions and subroutines. So, let's get started. I'm going to open up a file called functions.f90. Oh, so I looked into the whole file extension things. And according to the Fortran wiki, which is kind of, aside from the Fortran technical committee, the Fortran wiki is kind of the end-all be-all, as well as the comments someone left on the repo. It really is best to just use the F90 file extension for your Fortran source files. There's an interesting thing about Fortran. Fortran doesn't actually care. The language itself specifies nothing in terms of file extensions or anything like that. It is even entirely ignorant of files stored on a disk on a computer. Fortran says the Fortran standard says nothing about that, which I thought was really interesting. So it doesn't limit itself to computers with our kind of standard memory systems. Don't ask me what computers exist that don't have a standard memory system, but anyway, that's beside the point. The point is, use the .f90 file extension. I'm going to have to go and update mockline at some point, but not today. Anyway, okay, let's start our program. We're going to name this function fun. So, let's see, let's come up with an example. So say I've got some array. I spend a lot of time with arrays, and we're going to go ahead and initialize this array, and we will say allocate my array. Let's declare a size here, n is equal to 100, and we'll make my array 100 long. And then we'll go through a do loop. And we will set my array I to I. Okay, so we're just going to initialize this array to count from 1 to 100. Now let's say I want to go through and I want to process this array and do some kind of operation on it. So I could do I equals 1 to n, and I could say my array I is equal to, we'll go 2 times my array I plus 5. Do just kind of an arbitrary processing. But let's say I want to just do that a few different times. This is a really contrived example, but it's what I can come up with on the spot. Say we want to process it again. It's kind of, 1, it's laborious, 2, it's bad coding practice, 2, it's bad coding practice to have the same block of code multiple times. So, rather than having this process and process again, having the multiple for loops, what we're going to do is we're going to create a subroutine. Okay. Real quick before we talk about what we're actually doing with that, let's talk about what is the difference between a function and a subroutine. Anyone watching this, please correct me if I'm wrong, but as far as I know, the only difference between a function and a subroutine in Fortran is that a function returns a value, a subroutine does not. Okay? Both take in arguments. Both are allowed to manipulate those arguments and pass them back, but a function will have a return value, a subroutine will not. We'll look at what that is. So, in order to declare a function, I need to say that my program contains, and I'm going to create the function declaration. Now, a function, you say function, and then you give your function name. We will call this process array. And then we give it the arguments that we're passing in. Oh wait, I apologize. I wanted to start with a subroutine. Okay, we're going to start with a subroutine. It looks like this, pretty much the same as a function. There's a slight difference, we'll talk about that later. Anyway.
So it autofills all of that stuff in?
That's my linter, that's the modern Fortran linter that's doing that.
Okay.
So I'm going to name my subroutine process array. I'm going to have, this time I'm just going to have one argument, array, so I can get rid of this arg2. And this subroutine needs to know what is being passed to it. Again, Fortran is a strongly typed language, and so whenever you're creating functions or subroutines, they have to know what you're giving them. So I'm going to tell you, well, this is a real array that is allocatable. And we will talk about intent in just a second. I just want to go over the very basics of this. Again, I want to make sure I'm using implicit none so that Fortran isn't assuming anything, or the compiler isn't assuming anything. And we'll just say processes the array. Integer I. Okay. And then we will process it. Do I is equal to 1, 2. Now, here's the tricky thing. This process array subroutine doesn't know how big this array that you're giving it is. Because you've specified it as allocatable and you've put in the colon for the dimension, it doesn't know at compile time what that is. There's a couple of ways we can handle that. One way we can do that is simply saying size of array. That is, size is a function that will give you the number of elements in the array. And so this will loop from 1 to the size of the array. And I'll just copy this line here and use it down here. Okay? Yes, thank you. Array. There we go. Okay. Don't know why it's thinking I'm not using I. Masks variable in parent scope. It's because I have I already defined out here. So that's, what's that?
It cares.
It does care. And that's kind of one of the interesting things about defining a subroutine here in your program with this contain statement, is that anything out here is still in scope inside of this subroutine.
Could you create functions and subroutines outside of your main?
Yes. You do that using modules. We'll talk about that probably another. We'll talk about those another day.
But I guess a better way to ask that is before, like outside of your program, even within this file.
Yes, that is using modules still.
Okay.
Yeah, we'll get to that another day.
Okay.
I need to do a little more research on that. Anyway, to avoid that, we'll just explicitly say we're going to use a different variable here, just to keep things clean. So, let's go ahead and run this. Fortran functions. Oh, and I guess, I'm not calling it, am I? So rather than running those two do loops, I can just say call process array, my array, and I can do that twice. So you always have to include this call statement here when you're using a subroutine. That's saying, hey, go call this subroutine. That's pretty straightforward. And then, we can just write out my array. Okay, so that's the array that has been processed now twice. I can process it 3 times, and we'll get, yes, thank you, I do need to recompile. And we get a somewhat different answer, or we get it reprocessed again. So again, it's good coding practice to make sure that anytime you've got some chunk of code that's repeated, don't repeat it, put it in a function, call the function multiple times, or in this case, the subroutine. Now, I talked about, sorry, you were going to say something?
I guess my question is, I'm seeing that it's updating my array with each time that you call process array.
Mm-hmm.
is there a way to go back to the original myArray and because you made this array with 100 values or whatever in there, and then every time you call that function, it's updating what myArray is, right? And so is there a way to later be able to call back to the original one so that
You'd have to make a copy. So you,
okay.
you could do original array, and you could just say allocate
And just make another one, okay.
original array source is equal to myArray.
Yeah.
That's all you'd have to do.
Okay, cool.
But that goes along with what I was about to discuss. So when we initialized this subroutine, the linter filled in for us, and it had a statement here called intent. Now, declaring the intent of a argument to a subroutine is not required, but it is very good practice, and I recommend it. Intent is telling the compiler, hey, this is what I intend to do, or use this argument for in this function. There are three types of intents. There's in, there's out, and there's in out. In means I want this variable to come, or I want this argument to come in, and I want it to remain unchanged throughout the execution of this subroutine. So it's taking this argument in as is, and it's saying, I'm not going to change this, I'm just going to use its values, but I'm not going to change them. And so you can tell my linter is getting mad at me, and it's saying, hey, dummy argument array with intent in variable definition context assignment. So you're saying, hey, you're trying to assign a argument that you declared as intent in, and if I try and compile it, it's going to get mad at me. So rather, I can declare this as intent out. Now what intent out is saying, I don't care what array is, well, so this isn't the right way to do it either. What out does is says, I don't care what array is when it comes in, I'm going to treat it totally anew in this subroutine, and I'm going to give back the values that I created. And so what out does is out actually wipes or will reallocate variables. So if you've allocated something out here and then you pass it to a function or a subroutine or a function where it has an intent out attribute, that subroutine will reallocate it. And so if we compile this and run it, oh, we get a segmentation fault. That's exciting. I think it's because it's wiped the, no, I think it's actually wiped the allocation. Yeah. It doesn't know how long it is. So we would actually need to go in and reallocate this array
Within the subroutine.
within the subroutine. So we'd have to have something in here that we'd have to do allocate array n. And again, we can use n because since subroutine is contained within the program, these program variables are still in scope for the subroutine. Okay, and now you can see it's got kind of just random numbers in it. And if we do it a whole bunch of times, well, they stay the same. It's apparently allocating the same chunk of memory every time I run this. So that's not what we want either. What we want in this case is the intent in out. In out is saying, I want to keep the values that are being passed to me, but I'm going to change them. So it doesn't reallocate it when it's coming in, and it preserves and it allows you to make changes inside the subroutine. So if we recompile this, then we get the behavior that we wanted. Okay? Like I said, it compiled just fine without the intent. Best practice is be explicit about your intent. It will keep you out of trouble. Especially explicitly telling the compiler intent in, because if you know, hey, I'm bringing this in, I don't want to change it, and then you try and change it later on, or you inadvertently change it later on, the compiler will get mad at you, which is a very good thing because you don't want to change it.
Right. So in this case, we have a subroutine. Is is the reason you said that a subroutine does not return values because it's just manipulating values and then not storing the previous values in memory? So is it like a memory thing that makes it different from a function?
No, so it's not, and I don't know about the memory management, but well, let's just show what a function does. Let's say we wanted to create a whole bunch of these types of arrays. And so we could create a function that we call generate array. And I'll show you what that looks like. Function create array. And the only argument we'll give to this is we'll tell it how long we want it to be. To avoid the scope things, I'll call this num elements. And the result it will give, we'll call it new array. So a function, rather than unlike a subroutine, a function will give back a value when it's called. And that value is what's declared here in result. So if I go in here and I say, okay, integer, intent in, yes, I want num elements to be intent in, I don't want to change that. And then new array, we'll say is real, dimension, allocatable. You don't have to specify intent with the result of a function because the intent is always out. Pretty straightforward. And we'll just go ahead and do it like we did up here. Instead of making it 100 long, I want it to be num elements long. Gee, I typed that. I created this poorly. So rather than doing that right there, what I can do now is say my array is equal to generate array, and then num elements is n. Okay, so a subroutine we call using this call statement, and it doesn't create any new variables. It only deals with the arguments that you give it. A function you call using an assignment statement, and it will take all of the arguments that you give it as well as generate some new variable and give it back. Does that make sense, the difference? Okay. Let's just go ahead and compile this and run it. And there we go. Now a function can act like a subroutine. So if I wanted to, say I wanted to do like you were saying, Spencer, and maintain our original array, I could come and, rather than having a subroutine called process array, let's create a function called manipulate, or we'll call it process copy. And this will take in some array, as well as it will give you a new array. And so now, rather than taking this array and manipulating in place, we can, we're going to create a copy and then give back that new copy of the array. We could also process the original array inside of there. So let's just have a look at that. Implicit none. Steal this definition here. Again, I'm going to say this is in, out, or for now, I'll just put this as in, and then real dimension allocatable new array. and I'll copy all this. And first what I'll do is I'll allocate the new array, say source is equal to array, and then actually rather than copying that, I could just call the subroutine process array and do that on the new array. And I don't even need that integer variable declared there. So now what this will do is it'll take in the array, it'll create a new array that is a copy of it, and it will process the copy. Now say I wanted to do both. Let's see. My array, my new array, and let's say my new array is equal to process copy, and I'll give it my array. Okay, so first let's just run this and see what it does. So now we've got our original array, which is just counting from 1 to 100, and we've got the processed array here. Okay? Let's say I want to process my array as well as generating a new copy and processing it. So I could come in here and I could also do call process array, and that will process this array that we already passed in. Now again, it's getting mad at me because I've declared intent in. I've said I don't want to change this. So I need to go in and say, I want this to be an in-out intent, compile that, and now we have both arrays processed. So that's what I mean when I say functions can act like subroutines, because functions can still manipulate their arguments. And so if you've got a function where you need to pass back multiple values, usually the best way to do that is using a defined type, and we'll talk about those later. But another way you can do that, and sometimes it's the best way to do it, is you can have one of them just be the result of the function, and then pass a couple dummy arguments that are intent out, and say, hey, these are the other values that you're going to need coming out of this function. Okay? That all makes sense? Okay. I think that's it for functions and subroutines. Again, they're essentially the same. The only difference is that a function returns a result, a subroutine does not. Oh, and I'll mention Fortran does have the keyword return. For functions, this result here, it'll simply give back whatever new array is at the end of the function. So whenever the function terminates, whatever new array is, it'll give back. If I wanted to terminate the execution early, say I've got some logical statement here where I've got if something happens, then I could just call return and then the function will exit, and if that isn't met, then I could do more code down here. Okay? So that's the use of the return statement. That's like we talked about last time with cycle and exit for dealing with loops. Return is how you control execution of functions and subroutines. Okay? That is it for this video, I think.